everyone. Today I will be showing how to solve a few problems from Quantum Chemistry 7th edition by Dr. Levine. I will be solving problems from chapter 1 in today's videos. The first problem I'll solve would be the exercise problem on page 15, which is given right after an example problem on page 15. There are also a bunch of other problems that are given at the end of chapter 1 on pages 19 and 20, which I will solve in as much detail as possible in my next videos. So let's get started with this one. In this problem, we are given a state function or a wave function, psi, and the parameter a is given as 1 nanometer to the power -2. We need to find the probability that the particle is found between x equals 1.2 nanometer and 1.2001 nanometer. And the problem clearly tells us to treat this particular interval as being infinitesimal, which is really easy because it simplifies our lives. The probability is computed as psi squared times the interval. However, if the interval is not infinitesimal, let's say we have to find the probability of the system being present between x equals 2 nanometers and x equals 5 nanometers. Now that is not an infinitesimal interval. In that case, we would have to integrate over this probability. However, in this case, we only have to deal with an infinitesimal interval where dx is actually 0.0001 nanometers. So all we have to do is we need to compute this particular term, and that would be the probability. So let's get started with computing psi squared. So 32a cubed by pi, I have a 2 there because it's squared, times x squared times e to the minus ax squared. This term is also squared, so I'm going to insert 2 there. Now I'm going to split the power over these two terms separately to show how the units work out. In that case, that would be 32. It would be 32 by pi to the power half times 1, the value 1, you cube it, you take the square root, it's going to be 1. We have a unit of nanometer to the power -2. That will be, we have a cube here, so times 3 times, this gives us a half, times, we're going to take x to be 1.2 nanometers. So that would be 1.2 squared times nanometers squared times e to the power -2 times 1 nanometer times 1.2 squared nanometers squared. Now this and this gets canceled, the units. So the exponential term, it's basically unitless. I have computed 32 over pi, the square root in advance. So it's something like 3.192347 something times, we have a nanometer squared here and nanometer raised to the power a -3. So these two terms together will give us this, and this is 1.2 squared. So this entire term, 1.2 squared times the exponential term, gives a value of something like this. I computed this in advance. Let me change the color. And this term and this term multiplied would give us the value. It would give us this value times, or just this. Now we need to multiply psi squared by dx, which is 0.0001 nanometers. So the nanometer, the unit gets canceled out, and we end up with 0.000258, which is precisely the answer indicated after the exercise. So this is how we solve the exercise problem. It's very similar to how the example problem is solved. Now, in my next videos, I am going to solve the problems at the end of chapter 1. I will not be summarizing the key concepts in the chapter, but as I keep solving the problems, I will definitely discuss the key concepts that were used in solving the problem. So essentially, by the end of all the problems, we would have actually covered the entire chapter, the key concepts, and everything in it. Plus, we would have solved the problems in detail.